Mean of ungrouped data. In this lesson, we will be going to define mean as a measure of central tendency, and we will compute for the mean of an ungrouped data. Mean, otherwise known as average, we symbolize mean with the symbol x bar for sample and the Greek letter mu for population. The mean is also the most reliable measure of central tendency. To compute for the mean of an ungrouped data, use bar x equals to the summation of x divided by n. The summation of x equals to the sum of all the data, and n is equal to the number of data involved. For example, solve for the mean of the following data sets: 56, 35, 12, 20, 14, 28, and 15. We will again use this formula. Then we will add all the data and divide the sum by the number of data values. Adding all the data, we will then arrive with the number 180. And by dividing 180 by 7, we will get 25.71. We will then round the number to the nearest hundredths. Here is another example: 19, 35, 26, 50, and 0. Feel free to pause the video because in the next 10 seconds, you will try to solve the following data sets of 19, 35, 26, 50, and 0. Once again, we will use the formula. If you are wondering if you need to include the 0 to the data sets, since we added 0 to the data sets, we need to put 19 plus 35 plus 26 plus 50 plus 0 divided by 5. That gives us 130 divided by 5, which is 26. And that is how you calculate the mean of ungrouped data. The next topic will be about the mean of grouped data. The mean means the sum of all the numbers in the dataset divided by the number of elements. Here is an example of a frequency distribution table. This is the formula on how to calculate for the mean. The first step is to find the midpoint of the IQ scores to find out the mean. To find the midpoints, you must first add the bottommost numbers and the topmost numbers together. Then, you divide them by 2. And for our example, the midpoint for the IQ scores 81 to 90 is 85.5. These midpoints must then be multiplied by the frequencies of the corresponding classes. The sum of the products divided by the total number of values will be the value of the mean. The next step is the summation of all the frequency. The next step is to add all the frequencies together to make a solid number. Then you divide the frequency to the function. In our example, the mean is 109.2. We will now move on to the next topic. Good afternoon. Our next topic will be all about standard deviation of ungrouped data. For an example, we will be trying to find out the standard deviation of 6, 7, 8, 9, and 10. First step is to find the mean, which is x. Here we have our data 6, 7, 8, 9, and 10. We will be trying to find out the mean for these 5 numbers, which is 6, 7, 8, 9, 10. The sum, which is 40, divided by the numbers that are included, which is 1, 2, 3, 4, 5. 5. And the solution to this is 8. So our x bar will be 8. Next, we will be finding out x minus x bar, which is you find the difference of 6, 8, 7, 8, 8, 8, and so on, which is negative 2, negative 1, 0, 1, and 2. Next, you will be finding out of the power of 2, which is 4, 1, 0, 1, 4. Then you will be finding out the sum, which is 10, and then you divide that by the number by 5, because there are 5 numbers here, which is 2. Then you will find out the square root of the number, which is roughly 1.41. And that is an example on how you should find the standard deviation of ungrouped data. And that is an example on how to solve the standard deviation of ungrouped data. Thank you for watching and taking your time to listen with me. This is Sean Gabriel Ovizara saying goodbye and have a good day. Thank you for your cooperation.